Let's continue our experiment. And this machine.rs is having a unused function. We'll just remove this. Check if everything is fine. Cool. So the Indian slots are a little bit different from that of the US slots. So what we additionally require in the Indian slot is to add the scientist name. So let us pass the scientist name as a ampersand str. H is Baba, and S is for Satish Dan. 22 is for Ramanujan. It's for Vikram Balal Sarabhai. And the 7 is for Chandrasekhara Venkatraman's. They're not those. So we wrote a first variant test case. We have two kinds of slots. How about we create, we call this as US slot, and then we create one more thing called as Indian slot. I have to do the bare minimum to make the test pass. That's the trick. And this is going to have the same structure, except for it has a name. String. You can hold a ampersand str as well, but it will tell you some bullying things like it misses some lifetime parameter. So to make the story easy for you to digest, I will make this a string until we discuss the lifetime specifier on another occasion. And we have a slot now, and this is a US slot, and we have a Indian slot. This is again an experiment. I do not know whether I will reach the objective if I am going in this way. This is the Indian slot. Every experiment is where to learn things. If it doesn't work, at least you learn that okay, it doesn't work. And we need a implementation for US slot, and we are touching a lot of and Indian slot requires an additional parameter name, and that we are passing here as an ampersand str. Internally we will convert that into a string. We cannot just use the same auto identifier here because the variable are of two different types. So let me use name dot to string to make the inbound name as string. I have written an Indian slot now. One of the great principles of object orientation is program to an interface than to an implementation. And the second most interesting or the most loved suggestion from the world of object orientation is favor object composition over inheritance. Fortunately, in Rust, there is no such concept of inheritance. But achieving this programming to an interface than to an implementation is a little different from that of your other languages. So languages like Java facilitates this program to an interface by directly giving you a keyword called as interface. You can create an interface and you can declare the method that what you want the implementers of this method should provide a concrete implementation for that. And the Rust way of achieving this program to an interface is through a concept called as a trait. Trait is the common characteristics that what the US slot and the Indian slot have. So what is the common characteristics for both of them? It is just to provide the unit and the value. If you go to this method, we are just accessing this dot value and the unit. So if I have a slot, I mean, if we make both this Indian slot and the US slot implement a common interface, then most probably I can pass it here. So this way, we can make our first assumptions to pass. That is, we can at least created lesser damages to the outside world. You will just watch that. So let me do that now. So let me start with a trait, because I have to expose the US slot and the Indian slot through this trait, trait slot, and what is a common between this US slot and the Indian slot, an ability to access this unit and the value. So it is more like I have to offer only a getter for this and a getter for this unit and value. So this trait is going to have two getter methods. So we won't use get unit or get value, rather we'll use the same signature of this the struct member, because struct is, I have not told you what a struct is. Struct is a type that helps you to create a type of types. For example, you can consider your slot as a new type that you have created using two other types, a char and a i32. And for char you are calling this as a unit, and i32 you are calling this as a value. And this way, struct, you can think of this from a different dimension, that struct is a way for you to create new type. In fact, that's what the definition of Rust also about a struct, a type, to help you to create a type. And a vector is a struct, string is a struct. And you can learn, in fact, a lot just by opening this a configurable growing array type. And if you get into the signature of pub struct vector of t. So vector itself is a struct. It helps you to accept anything or any type. So this way we have two struct or two types. One is a US slot and Indian slot. The common characteristics or the common trait of this both are ability to offer the unit to the outside world, char, So we are not allowing anyone to make modification to this. It is just a getter method value, and this is a I32 type, and I have to use a semicolon for this. Now, how to make this particular program to accept a slot. So now the size for the value of type cannot be known at compilation time, does not have a size known at compilation type. Help the trait is not implemented, blah 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 stuff. We'll come to that later. Everything is very, very important. You'll learn that. Now, let me implement slot for your slot. Same. So, this way, your slot, by implementing this trait and by implementing Indian slot, now we can pass them to this vector of slot. That's what is my idea. So let us check whether my idea works now. But there will be some duplication of code. Fn unit, and Fn unit needs to access this unit. So how to access the unit of this US slot? So now I am going to introduce you to the other kind of a function. In fact, that is a function that the signature that what we normally will use. We'll seldom will use this associative function. So when you are using associative function, for example, you are calling this Indian slot : new. So a non-associative function is called as a self function, and you have to declare that then as self, ampersand self. So if we have that, then it's going to have an ampersand self. Once if we have the self, then you can return the unit, and this is okay. It's very easy for you to understand. There are two kinds of function a struct can offer you. One is an associative function that won't have a self. That's the reason you use this new function that is associated with Indian slot or US slot. When you are using a function that has a ampersand self, that means you are going to access the internals of the implementer, I mean the struct here. So this unit method, so if you find it very confusing, you just put here get unit and get value. So you can think of this now like get unit ampersand self. This self is equivalent of the same your slot. Now you can access a dot unit of this. So a common custom is we won't put get here, because this method itself is telling you that you are returning something. So it is a get method. Get methods normally will return you something. And the next is get value. This is of I32 and value. Just for this cheap reuse, people will get into the trap of inheritance, and that will lead to a lot of other damages in the long run. So we are not going to follow something just for cheap reuse. Now our US slot and Indian slot are having a common trait slot implemented for that. That's how you can read this. Now, if you come here, now instead of I'm accepting a slot, ampersand vector of slot, what now I can do is that I can put this here, T here, type, and the type is type slot, right? So we have made this method to accept slots of some type that implements this or that has a common trait of a slot. That's what does it mean. It is just a syntactic sugar-coated thing to tell you something. This is a type, and that type should include in other words, you can pass to me, that is me in the sense the exchange for method. I'm just talking from the shoes of this exchange for. You can pass to me any type as long as it implements this trait slot. So what are the things that implements this trait, or what are the things that has a common trait? In this case, it is an Indian slot and the US slot. The only difference is this name. We'll come to that shortly. So this is our first thing. So now this slot is just a interface, and in order for it to access the value, now we will simply call this value. That's it. So we did something that is very adventurous. We have the same method, but we did some nonsense here. If you think, yeah, we introduced a slot, which is a trait, and we made the old slots. We gave a different name for this old slots, and we implemented this slot to this US slot and Indian slot to expose the internals of the struct. And I told struct is a way that you can create new types. And we have the exchange for what happened to our features. Yeah, all the errors gone. Let us check whether we are now where the error is. The error is in fact is in the main, and we'll go to the main. This is not a slot as it is a US slot. We'll continue to keep this. We'll for the time being we'll just remove these two lines, and we will provide a different implementation later. We don't want to focus on main now. Can roll back the changes of main later. Cargo test. Yeah, that passes the test. So we quickly learned what is a trait, but still it didn't help us to introduce the new requirement of printing the name of the scientist, or best wishes from Bose, best wishes from Ramanujan. Because the trait, by doing this, the trait restricts us to access only the methods that is offered through this slot. Now we cannot access this name. Okay, so we have reached one more dead end now. Okay. Now we will reason about this. Still we are going in circles, coming in circles here. Exchange for is saying the slots. Let us just think outside of the box. Let us try to introduce, let us try to create a metaphor where slots will be. I'm getting some idea. We can create one more struct called as machine, and we can have the slots there, and we can implement this exchange for to that machine. That's one idea. We'll try to do that now.